Hello, students. This is Mr. Ezra. Recently, we have been talking about polynomial operations, how to multiply polynomials, how to add, subtract polynomials, and for the most part, you've been pretty comfortable with that, I think. Today, we're going to introduce polynomial division, and polynomial division is actually going to feel a lot like something you learned in elementary school, where today we're going to use long division to divide polynomials. So before we jump into polynomial division, let's kind of try to remember how long division works. Okay, there were essentially four steps that we repeated over and over and over again when we were doing long division way back in grade school. The first thing we would do is we'd look at the number we were dividing. In this case, it's 8. And we would look at the first number and say, does 8 go into 3? And if it didn't go into 3, then we would say, does 8 go into 31? And we count how many times? How many times does 8 go into 31? So we might do some multiplication in our head to get there: 8, 16, 24, 32. Okay, 3 times. And if we got it wrong, we'd have to go back and change it. But in this case, 8 goes into 31 3 times. So you'd divide essentially 8 into just the first part. After that, you multiply whatever number you got times 8. 3 times 8 is 24. Okay, that's the second step to multiply. The third step was to subtract. We would take the 31 above the 24 and subtract 24, and that gives us 7. And that number that after you subtract should always be less than the number you're dividing by. So 31 minus 24 is 7. Our fourth step is to bring down the next number, and we start the whole process all over again. We divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down until we get to the end of the division problem. So in this case, we brought down a 0, we had 70. 8 goes into 70 times, no more than 8 times. So we'd say 8 times 8 is 64. Subtract 70 minus 64, which leaves us with 6. Bring down the next number, 4. How many times does 8 go into 64? Well, it goes in 8 times, and 8 times 8 is 64. So we have no remainder here. Remember, the remainder is the part that's left over. We have no remainder here, so 8 divides evenly into 3104, and it gives us 388. Let's look at a few more long division problems and just try to remember it. So when I look at 30, I know that 30 doesn't go into 10, so I'm actually going to look at 102. I'm going to ask myself, how many times does 30 go into 102? And I can kind of just look at the 3 and the 10 and say, well, 3 goes into 10 3 times, so 30 probably goes into 102 about 3 times, and I would try that out. Put it up here above this number. Since I went into 102, I put it above the 2. 3 times 0 is 0, and 3 times 3 is 9, and I would subtract. When I subtract 102 minus 90, I get 12. 2 minus 0 is 2, and 10 minus 9 is 1. And this number has to be smaller than 30 or I've made a mistake, and it is, okay? Well, 30 doesn't go into 12, but remember you have to bring down the next number, which is a 0. And then you ask yourself, how many times does 30 go into 120? Well, 3 goes into 12 4 times, so 30 goes into 120 probably 4 times. 4 times 0 is 0. 4 times 3 is 12. And since this is the last number that I have brought down, that 0 there, that means that when I subtract, I have no remainder of 0. 120 minus 120 is 0. So my answer would be 34. So we can divide with long division. Let's look at one more. Okay, so we got 16 dividing into 1077. 16 doesn't go into 10, so we have to go into 107. And I'm going to kind of estimate and say, well, 16 is about 20. 2 goes into 10 about, let's see, about 5 times. So I'm going to try 5. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. When I subtract 107 minus 80, I get 27. Notice that 27 is bigger than 16. So I've made a mistake, haven't I? So I need to go back and choose a larger number. So I might try 6. 6 times 6 is 36. 6 times 1 plus 3 is 9. And when I subtract here, I get 11. 11 is less than 16, so I know that I did it right. After that, I bring down the next number, which is a 7, and I do the whole thing all over again. I like to erase this once I've done that. How many times does 16 go into 117? Well, I know it goes at least 6 times. This is bigger than 107, so I'm going to try 7. 7 times 6 is 42. All right, and 7 times 1 plus 4 is 11. 7 plus 4 is 11. I subtract this. I'm at the end of the division problem, and when I subtract this time 117 minus 12, I'm left with a remainder of 5. Now, when you were like really young, you would put an r.5 over here. You'd say there's a remainder of 5. But when you got a little bit older, what you would do is you would say, well, 5 is my fraction, and it goes over the 16 that I was dividing by. And you'd say 67 and 5/16 would be the final answer. And that was long division. You've got these steps of divide, multiply, subtract, bring down, and you just keep doing it till you get to the end of the problem. And if you have a remainder, you put it on top of a fraction bar with something in the bottom. Polynomial long division uses exactly the same steps. So this you try it is one for you to try. And on your own, I want you to try this problem, 32 divided into 3104, and see what you can do. And we'll talk about this in class the next time I see you. All right, so long division is going to be very similar. We're going to start by rewriting the division problem as a long division problem, just like we did in the first few problems. And once we set it up, we're going to approach it in the same way. Remember, the steps were first divide. So we are going to divide. Now, when we do this, we are only going to use the first term in both parts. So I'm going to ask myself, how many times does x divide into 5x to the third power? And a lot of times I'll just come off to the side and actually just divide those two things. 5x to the third divided by x is 5x squared. And once I divide that, it goes on top of the x squared part. I like to line them up. So the x squared part that I get is going to go above that one. The second step, once I divide, is I multiply. I'm going to multiply 5x squared times x minus 2. So 5x squared times x is 5x to the third power. And 5x squared times negative 2 is minus 10x squared. Now at this point, I'm going to subtract. You must remember that when you subtract, you're subtracting this term and this term. You're subtracting them both. Well, when I subtract a positive, I subtract. When I subtract a negative, I actually end up adding. So it's really important that you change both of these signs before you subtract down. And then we're going to do our subtraction. So 5x cubed minus 5x cubed cancels out. That should happen every time. Negative 8x squared plus 10x squared is positive 2x squared. Okay, so that, we didn't write it over here, but that was our third step, is to subtract. And when you subtract, you have to basically, whatever the two signs are, you're going to do the opposites to subtract them. Okay, and our final step is to bring down. And in this case, we just bring down the next part. In this case, it's minus x, so bring down the minus x. And now we just repeat that process over again, just like a minute ago. Just like with regular long division, we just keep going until we get to the end. So I ask myself, how many times does x go into 2x squared? And I just come off to the side and I say, well, how many times does x divide into 2x squared? And I see that it goes into x times, because x squared divided by x is just x. And that 2x goes up here on the top, positive 2x, so we put plus 2x, need a sign in front of it. We multiply now, 2x times x is 2x squared. 2x times negative 2 is minus 4x. You should always notice that the first part here and here are always the same until you subtract. So it should be the same until you subtract. Now we'll subtract minus 2x squared but minus negative 4x becomes positive or plus. So I'm changing both of those signs so that I can subtract. Those cancel out. Negative 1x plus 4x is 3x. And I bring down my last part, which is minus 4. Minus 4. All right. I repeat one more time, x into 3x. And I come off to the side and I say, well, how many times does x go into 3x? It goes in 3 times. So I'm going to have plus 3 over here. And you should notice that these terms are in descending order. I had an x squared and then an x and now a constant. It always is going to kind of work that way. 3 times x is 3x. 3 times negative 2 is negative 6. When I subtract, the sign changes for both of them so that because I'm subtracting a positive here, but subtracting a negative 6. And I add down or subtract down, and I cancel out the 3x's. Negative 4 plus 6 is 2. That 2 is called a remainder, right? We have a remainder of 2. Just like with fractions a minute ago, this 2 is going to be part of a fraction. It's going to be positive or plus 2 over, and then what I was dividing by will be the denominator, x minus 2. And my answer to this problem is 5x squared plus 2x plus 3 plus 2 over x minus 2. My last example for today is 6x cubed plus 16x squared plus 3x minus 2 divided by x plus 1. Remember that we first have to write this as a division problem. So we're going to divide x plus 1 into 6x cubed plus 16x squared plus 3x minus 2. Now, x goes into 6x cubed 6x squared times, and I'm going to put that right here above the x squared part. I know because x goes into x cubed, x squared times, and if I come off to the side, I can divide this off to the side. You just kind of learning how to do this, you might want to do this every time. 6x squared times x is 6x to the third. 6x squared times 1 is plus 6x squared. Now I divide. I'm sorry, I said that wrong. Now I subtract. Minus 6x to the third, and this is going to change to minus 6x squared because I changed both signs to subtract them. 16 minus 6 is 10. Bring down the next term. Start over again. X divides into 10x squared. 10x times, so that's what I write up top, plus 10x. I multiply 10x times x plus 1. It's like distributing it to get 10x squared plus 10x. That's 10x times x goes here. 10x times 1 goes here. When I subtract, I have to change both signs. 10x minus 10x cancels out, and they should always. 3 minus 10 is negative 7x. Bring down this last part here, minus 2. And I do it one more time. I ask myself, how many times does x divide evenly into negative 7x? It goes in negative 7 times. Goes right there. Then I multiply. Negative 7 times x is negative 7x. Negative 7 times 1 is negative 7. And we, again, must remember that when we subtract, the signs change. We're subtracting a negative 7x, which means we're adding. We're subtracting a negative 7, which means we're adding 7. So both of those signs change. We cancel out the 7x's. Negative 2 plus 7 is positive 5. That is the remainder, right? That's the remainder. But in this problem, we put plus the remainder over what we were dividing by, x plus 1. That is the polynomial that we wanted as our answer to this division problem. Again, same steps as long division. You learned this when you were in like 3rd grade or 4th grade or something. It's divide, multiply, subtract, bring down, divide, multiply, subtract, bring down over and over again until you get to the end, and the remainder goes over whatever you were dividing by. That's like a middle school concept probably. That's it. In the next video, we're going to go a little deeper. We're going to look at some problems where there might be something extra that you have to do, but for the most part, that's it for long division. So we've got a few more examples on long division in the next video. Stay tuned for that.